Hello, folks. Starting this week, we're going to be starting to take a look at something a little different. We've been doing a lot of work with equations and solving and graphing equations and things like that. But one of the things we need to do before we finish up this class is talk a little bit about inequalities. Okay, so mathematical sentences that have symbols other than an equal sign. And these two symbols should look something, somewhat familiar to you because this is your less than sign and this is your greater than sign. And so you use these in the younger grades when you were looking at things. You would maybe write a statement like this, 2 and then 3. And this meant 2 is less than 3. Right? We always read the statement from left to right. So that's why we consider this the less than symbol, because you're going to read it from left to right. So 2 is less than 3. You remember back when you were in elementary school or whatever, they always told you, the alligator eats the bigger number. Right? So if it's open this way, then the smaller number is going to be over there, so that this would read 2 is less than 3. Right? And we could put it reversed. If we reverse it, then the 3 has to go over here, and the 2 has to go over there, right? 3 is greater than 2, right? 3 is greater than 2. So these are your two main inequality symbols. I'm going to show you some other ones, but our less than symbol and our greater than symbol, right? It always is open to the bigger number. So in this case, this is the less than symbol because 2 is less than 3. This is considered to be the greater than symbol because 3 is greater than 2. Okay? So you always read it from left to right like that. Okay? So we can use variables here and write some variable sentences here. And let's make sure we understand what they mean. If I write something like this, what does that mean? Right? That means that x is less than 3. Right? So what type of numbers could we plug in for x? Anything less than 3. Right? So 2 or 1 or 0 or -1 or -2. Right? Anything less than 3 would be a solution to that statement. X is less than 3. Okay? Now, what if I made one change and I wrote this? This, now notice the less than symbol has a little line underneath it. And what that means is that x is less than or equal to 3. So here, you could not plug 3 into this as a solution because 3 is not less than 3. You could plug in 2. You could even plug in like 2.5 because that's less than 3, but you could not plug in 3. Here, you can plug in 3. 3 would be a solution to this because 3 is equal to 3. 2 would be a solution, 1 would be a solution, 0, -1. All the same numbers that are solutions to this would also be solutions to this. The only number that this one has as a solution that this one does not is 3. Okay? So this means less than, this means less than or equal to. Okay? So the only difference between these two is that this one includes the 3 as part of the solutions and this one does not. Okay? Now what if I flip that symbol around and I said like this? Now that means that x is greater than 3. So x can be any number bigger than 3. Not equal to 3, bigger than 3. So how about 3.5 or 4 or 5 or 6 or 7? Any number bigger than 3 would be a solution to that inequality. Bigger than 3. Right? And then just like up here, if I make one small change and I put the line underneath it, all that means is that now x can be equal to 3. So now you would say x is greater than or equal to 3. So x could be 3 or 4 or 5 or 6 or 7. Any number 3 or greater. So the only difference between when there's a line underneath or not is that when there's a line underneath, that means equal to, so it means it can include that number. If there's no line underneath, then it does not include that number as part of the solutions. Okay? So how many solutions does each of these have? How many numbers are there that you could list as solutions? Well, the answer is an unlimited amount, right? An infinite amount. If I was trying to list all the numbers less than 3, there's an infinite amount because there's an infinite amount of numbers in our number system. So if you were trying to list the solutions to these, you really can't list them all. It's impossible to list them all. So a lot of times what we'll do is we'll draw a little number line diagram to show where all the solutions are. Okay, so let me show you how to do that. Okay, instead of writing this out like this, I'm going to show you how to do this with a number line. So let's say, for example, I want to show all the numbers, all the solutions where x is less than 3. So I'm going to draw a little number line. 0, 1, 2, 3. Okay, you put some negatives down here. Okay? So you want to draw a little number line and just make sure 3 is on the number line, which it is over there. So now what I'm going to want to show is where are the numbers where x is less than 3. So here's 3. So what I'm going to do is I'm going to put a dot on the 3, above the 3. Now notice I put an open dot though. And the reason I put an open dot is because 3, as we mentioned, is not a solution to that. So I put an open dot. And now, where on the number line are the numbers less than 3? Over here to the left or over there to the right? Hopefully you said over here to the left, right? 2, 1, 0, -1. Those are all the numbers that are less than 3. So I am going to draw an arrow here above the number line showing that these are all the numbers that are less than 3. Anything below 3. And so the arrow shows that that's going to go on forever. Okay? So instead of listing the solutions, a lot of times we draw out a little diagram number line like this showing the solutions since there are an infinite number of them and we can't list them all. Okay? So let's do the same thing down here with x is less than or equal to 3. Okay, I can draw kind of the same number line. Could even slide 4 in there if I wanted, just to be. Okay? Now, the only difference between this inequality and this inequality, we mentioned, is that here 3 is a solution because of the equal sign. Right? So, when I go to 3 and I put my dot, instead of making it an open dot, I am going to color it in. Because that means that 3 is a solution to that inequality. 3 is included in the solutions. From there, the rest of the solutions, it's less than, so are still this way. So I will still draw the arrow going that way. So this is saying that x can be anything 3 or less. So because the dot is colored in, that means it includes 3 as a solution. Okay? Over here now, what would it look like if I graph these two? Now I'm going to draw the number line a little different. I'm just going to put 0 here, 1, 2, 3, not much different. I just want to make sure I include the 4 there. Now, once again, my boundary dot is going to go on 3. And since there's no equal to, then it's an open dot, just like here it was an open dot. But now for this one, the difference is that we're talking about where are the numbers greater than 3. So the numbers are greater than 3 over here. 4, 5, 6, and all the numbers that would be off the board. So when I make my arrow to show the solutions, I'm going to draw it going to the right. because that's where the numbers are greater than 3, over that way. So less than, the arrow is pointing this way, the solutions are going to be to the left. Greater than, the solutions are going to be to the right because the numbers get bigger to the right. So this is saying x could be anything that's bigger than 3, not including 3. That's why it's an open dot. Okay, and then this one, the only difference between this one and that one, you can hopefully maybe guess. The only difference is that now 3 is included in the solutions. So when I put my dot on the 3, it's colored in, right? But it's still greater than or equal to 3. So it's a colored in dot because it's equal to 3, and then greater than, the numbers get bigger going that way. So when you're trying to show the solutions and you have a problem that is less than, that has the less than symbol, the solutions are always going to go to the left. And when you have a problem that has the greater than symbol, the arrow is always going to go to the right. Okay? And whether or not the dot is colored in or not depends on if you have an equal to underneath or not. If you do not, that means it's not including that number, so it's an open dot. If it's an equal to underneath, that means that number is included, so it's a colored in dot. Okay? Now I use 3 here, but you can use any number. We can have a solution with any number. So before I leave you for today, let's just do another quick one. Let's say I threw up a couple more quick problems here. Just saying, well, what if we had, and what if we had those two quick ones? And we wanted to show all the numbers that make those true. So what does this mean? This means x is bigger than 5. X is greater than 5. So I would draw out a number line and make sure 5 is on it. So sometimes I put the number that I'm talking about in the middle. Now, I'm going to put a dot on 5. Is it going to be open or closed? Open is correct, right? Because there's no equal to, so it's not including 5. So I put a dot above the 5. That wasn't really above it. I'll do the best I can here. So now, x is greater than 5. So where are the numbers greater than 5? Over here or over here? These numbers are greater than 5, right? Over here. So the arrow goes that way. Greater than, the arrow goes to the right. So this is showing all the numbers that are greater than 5. Everything to that side of 5. But it does not include 5, so that's why the dot is open. Okay? For this one, make a number line. Again, make sure 7 is on the number line. Okay? So now I'm going to put a dot on 7. But since it's an equal to underneath, I am going to make it a colored in dot. Because it includes 7. And then this is saying x is less than or equal to 7. So where are the numbers on this number line less than 7? This way, right? So you draw the arrow going this way. So this is showing all the numbers that are less than or equal to 7. It's colored in because it includes 7, and all the numbers this way are less than 7. Okay? So this is what we're going to be working with a little bit, is we're going to be working with inequalities. These symbols of greater than or less than or equal to or greater than or equal to. So we're just going to be working with some problems that have these in them. So we're going to work real slow. We're going to practice with this. Make sure you understand what the symbols mean and then move from there. Okay? But this is just a little different than when you're working with equals, because when you're working with equals, you're usually getting one answer or maybe 2 answers, but usually you're only getting one solution. Here we have an infinite number of solutions because there's an infinite number of numbers that are greater than 5, for example. Okay? All right, so we'll keep working on this for the next couple weeks. Everybody have a good day, and we'll talk to you soon.